Okay. Presumably, I'm recording what's going on my screen right now, and we'll see how well that goes. And hopefully, if something goes wrong, if it stops, it'll tell me. Um, this is my first time trying QuickTime to do a screen recording instead of using iMovie. So, um, whatever happens from this, and presumably it's picking up my audio as well. I've tried that. Um, I will post this on the lectures page after. Okay. So a few quick items. Um, so I've already had a couple of students help me to, even in the smallest way, to improve a text. And like I said, I am including people by name. So there's two of you, and I hope to have more of you as the semester progresses. So um, keep reading closely and point out anything wrong, whether it's just with the English or the mathematics, or even if something. What we'll find out as we go through the exercises or the explorations. Um, if like for instance, the wording of a question needs to be changed, even if it's not just an actual mistake. Okay, and I see that people generally have their laptops up and ready, so they'll have. How many went with Octave instead of Matlab? Out of curiosity. Okay. Oh, wow. Okay. Well, I'm aware of at least one other besides you. Um, so I have. The funny thing is, I have Octave up here, so we'll be taking a look at that too. But I actually had trouble installing it. Um, this is an older version. This is 3.8. I tried to install the current, which is 4.2, and it's like no. I could run it, but not with this graphical user interface. You had to do a command line, which I don't think anybody wants to deal with that. Um, okay, but so we'll take a look at that also, and I have Matlab up and running. Now, one thing I want to make sure of, I imagine um, on this display, the text might be a bit too small. Um, what? What? Okay.
That was somebody in the hallway.
Oh, okay. Thank you for clarifying that. Um, okay. So, um, okay. Well, also we have font size that's not only too small; it's unlucky. So, let's. Okay. Is that good for everybody? The text here, even in the back of a room, and even people down there. Okay.
Sure.
All right. Say, speak now, forever hold your peace. So, okay. Actually, it doesn't seem to change. Hold on. Okay. Okay. Actually, I think I like that even better. Okay, the other thing I want to check out is so one thing I'm not sure, I'm probably mentioned somewhere in textbook, but not up front. So I want to make sure I go on record with it right away. Well, first, this is in the book. I'm going to start a diary so that anything I do in this command window will be a record of that, and I'm going to post that also. So, okay, and so if you leave this argument out, this file name that I've just made up, it'll write into a file called diary. Just that's it, just diary with no extension. And you want it's a good idea to give it an extension like .txt, so that, like for instance, if you're in Windows, you want to open this on Notepad later, or Microsoft Word, you can do that. So that's what I'll do here. Also, if you so this is something you might want to do when you are working on the explorations and save everything that you're doing, and then you can edit it later. And if you have your MATLAB session, you do a bunch of stuff in it, and then you quit, and then you come back, and then do the same direct command again to the same file, it will append to that file. It's not going to trash the old one. So that's a good way to keep everything that you're doing in one place. Okay. If you, very important feature, if you use a percent sign on a line, Bless you. So once you put a percent sign on a line, then everything after that's ignored. And the reason we have that is for comments. So, and you'll see in any code that I have, like in the book, for instance, that I make frequent use of comments. In fact, I often write the comments before I write the code. I'm laying out in words what I'm doing, and that helps me get the code correctly on, well, if not the first try, at least the second or third or 20th. Now, also, if I have something like this, so I can still do the statement like x equals 4, and then I can go ahead and put a percent sign later on the line. So everything, only things after the percent sign are ignored. This statement x equals 4 is still valid. Now I put actually I'm going to remove that semicolon. Okay, and we see it'll tell you that setting x equal to 4, it'll display that, unless you put in the semicolon. So that will cause the output to be suppressed. Often when I'm trying to get something working, I tend not to use semicolons, so I can see what's happening from one statement to the next, unless I feel really confident that the statement is correct. And then once everything is working, then I only want to output certain things, or maybe I don't want it to output anything, and then I'll put my semicolons in. So it's a primitive way of debugging what you're doing, to have it print certain things out as you go. And okay, it looks like seems the comment's also pretty readable. I've had to change the comment color in the past because sometimes people would have trouble reading it in class. Okay, but and also a quick tour of the user interface. So here, now this might look different for you depending on, for instance, here I'm on a Mac, but it might look a little different in Windows. Actually, okay, and then like which Windows you might have might be a little different, just because I've been using this for quite a while and I like to customize it. For instance, what you might have if you're a first-time user, and I imagine most of you are, you might have not like a very small command window instead of this big one, and then you have like a Matlab Editor. Actually, can someone show me? Does anyone here want to show me their display? I want to see what. Oh, so yours is the same. Freaky. Okay. I know it's different between or somebody with Windows.
Here.
Okay. Okay. Oh, this is exactly the same. Okay. Now, some of the research students have an editor in the window, and no, I can't do that. So if I pick one of these files, I'll just pick, let's see. These are old files from previous years. So here's the Matlab Editor, and so you can have as many files open as you like, and those files will be tabs. Like if I go ahead and open another one, then we just have these different tabs here. And where files are placed, it's determined, like up here, you see the directory that you're in. So by default, it'll be in just plain old MATLAB folder. So I've created a Mat460 subdirectory under this. So it'll create a MATLAB folder when you install it under My Documents on Windows, or just plain Documents on a Mac. And so you want to make sure, for instance, suppose if you guys are emailing code back and forth or something, you want to save it in the right place. And so so you need to look here to see what directory you're in, and make sure that files are put there. Like for instance, what if I send everybody something? That's where you want to save it. Okay, and so we have here like a bunch of .m files. You'll be creating .m files all semester long. The .asv, I think that's a Windows-only feature, is short for autosave. So sometimes it will back up your files. It might instead say like this file name with a tilde after it. That happens often on a Mac. and whatever other files I have here. Mostly M files, some images, like for instance from saving plots. In fact, as at least we'll have plenty of time for any questions you might have. Hopefully everybody's at least gotten a start on the explorations. So one thing about image files, I'm going to, and this is similar to what's happening in one of the explorations, I'm going to create a vector of x values with a spacing of 1/100th from 0 to 1. Now, if I stop here and just go ahead and hit enter, it's going to give me a... actually, I'm going to comment on what I'm doing. Creates a vector of equally spaced x values. But if I hit enter now and run this statement, it's going to create a row vector, which I don't want. I want this to be a column vector. And so by putting a single quote or apostrophe in here, that's going to take the transpose. Well, as you'll see, it's discussed in the book. It's actually transpose and complex conjugate. But these are real numbers, so who cares about the conjugate? So this creates a column vector of equally spaced x values. And I have no semicolon here, so it's going to print it out. So here are my x values. And what we see is only 5 digits. So this is the default format, format short. But if I want format long, then I can just type x at the prompt and have it display. And we have, so you can decide which format you want to use. Another interesting format that'll come into play in certain explorations is format rat for rational. So if I go ahead and display x there, then we have the simplest fraction that it can find. So we see like it simplifies 90 out of 100 to be 9/10. Now keep in mind though, it's rational functions, internally it's still represented as a double precision floating point number, which is going to be one of the topics from chapter 2. But the rational format is only for display, and what it does is it tries to find the best approximation to a certain error tolerance, best fraction it can find. So if I go ahead and I want the value of pi as a fraction, so I'm about to prove that pi is rational after all. That's the best fraction that it can come up with. If I want to ratchet up the accuracy, I can. Now, if I, out of curiosity, if I go back to format long and do 355 over 113, oh, not bad. Got the first 6 decimal places correct. Now, the reason I wanted to show you, we're going to plot the exponential function applied to this vector of x values that I have from 0 to 1. So if I do plot x, so first you put your x values, in which case is my vector x, and then my second argument are my y values, which would be the exponential function, whoops, evaluated at x. And, okay. And now we'll create a separate figure window, so we see the graph there. By default, it's going to be a blue solid curve, but I can use, if I want to change that, I can try it again with a third argument. For instance, I want a red dashed line, so I'll put in quotes, always single quotes in Matlab, never double quotes, R for red, and then a double dash for to make it a dash curve. And what happens is it will overwrite what was there before. That's gone, and now this is in its place. Often you want to superimpose multiple curves on the same plot. So to do that, I'll use the command hold on. Okay. So now when I plot, I'm going to plot something else now. Let's see, plot x. Let's see, exponential. If I want to plot the function e to the x times sine x. Now, expx is a vector. Sine x also a vector. You can't multiplying vectors isn't actually an operation that's, I guess, sanctioned in the world of linear algebra. But if I want to do component-wise multiplication, which is what I want here, that's dot star. So, so for instance, if you do A times B, where A and B are square matrices, that would use regular matrix multiplication as you're taught in 326. If you do A dot star B, it will multiply the entries component-wise. So sometimes you want one, sometimes you want the other. And I'll try, let's see, a magenta dotted curve. That's what the colon's for. And so now we have sine x plotted here. We're only going from 0 to 1, so we haven't really seen the oscillatory nature of sine just yet. Now, another thing you can do is, if you, well, because what I'm going to show you pretty soon is saving images, but a lot of times when you want to incorporate an image from MATLAB, say like in a PowerPoint presentation, if you just save it and include it as is, it might not show up well on a screen like this one when you put it through, run it through a projector. So for that reason, what MATLAB provides in their preferences, under figure copy template, you can set this up for inclusion in a document, like one of my research papers, for instance, or maybe something you want to submit as your homework, or presentations where you have a projector to think about. So for presentations, it will make the curves thicker, the text bolder. So if I go ahead and click that for presentations, so it's going to do all these things as soon as I say click on apply to figure, and there you go. So then now something that will show up better on a projector. I can do annotation. I'm going to dismiss this. I want to label my axes. X label X. Oh, okay. It's not showing up very well there. All right, and then Y label for label the Y-axis. Now, depending on the font size, it might not show up very well. So that's artifact of the large text size. Now, if I want to put a title, I can use a title command for that. So then the title will show up at the top. Good way to make your homework easier to understand, whatever plots you have to turn in. I can even put a legend to indicate which is which. So for instance, the first curve I plotted was e to the x. And notice I'm using the up arrow because that's going to let me do a superscript. And then I have e to the x sine x was the second curve. And that will put in a legend right here. And what I can do, if I click on this arrow here and click on the legend, I want to move it. I also want to make it bigger. Okay. Not sure what's, okay. For some reason it's not cooperating. Hello? Okay. Usually it's supposed to let me click on whatever I want. Like, notice the axes are selected, but it's not, for some reason, not letting me click on anything else. Oh, okay. That was not what I wanted either, but okay. All right. I think MATLAB's gotten confused, so I'm going to reproduce it. And this gives me a chance to show you something else. I can go ahead and I don't want to type in those commands again. I can scroll through my history using the up arrow or down arrow, so that helps. But I can do better than that. if I go to Layout and Command History, I can pop that up. Whoa, dude, where'd he go? Of course, MATLAB's going to act funny when I'm using it in class. Okay, I'm going to choose Docked. Okay, so now I see my command history all in here. If I want to run these commands again, I can just select them and right-click or whatever your secondary click is if you're on a Mac. I was Windows until 2 years ago, so that's why I'm doing my right-click on a Mac. I can evaluate the selection, and it'll just run those commands again and produce the plot. Okay, and sure enough, it's still not cooperating, so now MATLAB has managed to cause me embarrassment. So if you are following along and reproducing it yourselves, hopefully you can... I definitely don't want this anymore. I want to undock this. Okay. Wow. Okay. Yeah, that's going to cheese me off. That it's not letting me. Because usually I can, like for instance, if I want to delete one of these curves, I should be able to click on it and then delete it. But yeah, since I'm in class, it wants to embarrass me. So never mind. Dang it. Yeah. So, but yeah, you can try to position this presumably. Is anyone else able to try this? Like, I don't know if you're trying it yourself. Anybody? Yeah. Matlab or Octave? Matlab or Octave? Can I see what you... Yeah, that's extra freaky.
I did that thing where you copied the last commands.
Okay.
But it is one of the graphs.
Yeah. Yeah. Well, since you ran a bunch of commands at once, it probably is unclear which command you're referring to. Could I see the command window again? Okay.
And it said this whenever I did the legends.
Ah, okay. Okay. Yeah, I don't see anything off base in there. Oh, yeah, that sign there, that shouldn't be there.
Oh, right.
Yeah, you can't edit those. Oh.
That was from the command.
Okay, that might explain what happened about that strange, like, unknown class or whatever it gave you. Well, okay, you have a plot up, so are you able to, like, if you click on the arrow, are you able to click on other parts of the graph and highlight them, or like, it's like, yeah, oh, towards the top, like look on my window. So yeah, so you're able to click around, like okay. So for instance, if you click on the legend and like move it around, okay. So theoretically, it's still possible. Anyone else? Yeah. Yes.
Mine's not superimposing. Like it won't. Just be my error.
Okay. So in order to superimpose after plotting the first curve, that's when the hold on command is necessary.
Okay.
Yeah. And then if you don't want it to superimpose anymore, then you would do hold off, and then the next command would. So that would explain why it didn't superimpose.
So you do plot X.
Yeah. After this first command, okay. Well, in this case, I intentionally wanted to wipe it out. So plotting this, then do the hold on, then just once, and then all subsequent plotting operations will superimpose. Until I do hold off.
I think mine's just not plotting.
MATLAB or Octave? Okay. Are we experiencing a MATLAB revolt? About one thing that, I mean, I've been using MATLAB since 1991. So I've used many versions over the years. And just recently, like 2017, they've made some change which I find extremely objectionable. Where it used to be suppose you're adding two vectors. Well, the vectors have to be the same dimension exactly, and they both have to be either both row vectors or both column vectors. So row and column dimensions must be the same, which is what makes sense mathematically. So if I tried to, for instance, suppose I had a row vector of length 100 and a column vector of length 100, and I tried to add them. In the past, it would be an error, and that's fine. But now what they do is they do some sort of freaky outer product operation that blows up both into a matrix. And and if the vectors are really, really large, which is often the case like in my research, that operation takes forever. So all of a sudden you're doing something really simple, like adding two vectors, and all of a sudden your computer wants to shut down from overworking. So sometimes they've made some strange changes like that. But yeah, I'm really puzzled by this. Okay, so the reason I wanted to do anything graphics related in the first place was that once I'm satisfied with my plots and any annotations, I can just go ahead and do save as, and save it in whatever folder. And you can choose your formats. We have a bunch of image formats that are supported: JPEG, PNG, GIF, etc. But one thing I would strongly recommend is, and in fact, what I'm going to do, I'm going to save this format and then open up later and see if it still fails to cooperate. Matlab figure.fig. So I'm going to call this, stupidplot.fig, because I'm frustrated. And the reason why it's important to save that is that way you can open that up later and change things. Like if you want to have a different x-axis label or different title, you can do that. Whereas if I go ahead and save it as an image, so I can do that too, so stupidplot.jpg, and we see, you can see over here, we have the two new files that I've just created, because I've sorted by modified time. And that way, so JPEG, you can't go back and change that. So I always, it's just a habit, I save it as a .fig and then whatever image format I want. Okay. Now, so in spite of things not going like I wanted, well, but for the most part they did. Does anyone have any questions so far about what I've done? And questions from down the coast? Did anyone else try this and experience any other difficulties we haven't brought up already? Okay. All right. Now, I don't want to keep this command history. And apparently, this keeps track of command history like forever. Like sometimes I would actually use commands from literally years ago. So it's very helpful. Okay, so I'm going to get rid of this. Also, see over here, whatever variables you have, are listed over here, and if feasible, list their values. Like for instance, x is a vector of length 101, so it's not going to show me all the values. If it's a short vector, it will. And then ands, when I did that fraction, 355 over 113, I didn't save it in any variable. So it saves in a special variable called ands, short for answer. So if as soon as I do some other expression, like if I just do, if I want to print out the value of e, which is e to the first, I'm not going to save it in a variable. So now we see that value has changed. The old 355 over 113 value is gone. So that's something to keep in mind, that you have that variable that, and sometimes I've actually made use of that if I don't feel like saving it in something. Okay. Now, does anyone, I didn't mean to spend so much time on that, but that's okay. Does anyone have any questions about any of the explorations in section 1.2 that they've tried so far? Hopefully, most, if not all of you, have at least gotten the start on them. I mean, you still have plenty of time. This is due in 9 days. But these class periods are where we it's the best opportunity to get those kind of questions answered. So by all means, don't be bashful. Nobody? Bueller? This is what I was afraid of. So, okay. Now, there's one thing in particular that's not related to MATLAB that I wanted to go over with you anyway, because this is actually something that I picked up from a teaching workshop that I went to during the summer. Okay. Wow, it's still recording. Kind of amazed. So what I have here, actually, any of you who are planning to go into teaching, I've posted this paper on the course website under resources, the coverage issue. And that's strange. Okay, I thought I'd done websites for both these authors, but whatever on that. So this is a research paper from the math education community. And what I found interesting was they listed several beliefs that students in mathematics courses tend to have, and of course they have to use fancy jargon because this is a research paper, non-availing beliefs. And what they mean by that is a belief that does not support learning or that inhibits learning. And when I was in this workshop and we're going over these beliefs, I thought, wow, this is what my students are like. Because some of these non-availing beliefs, you guys as a whole definitely have. And it really, the higher level you go in mathematics, now we're at the 400 level, the more problematic it gets. So I want to point these out, that these are things that you should, beliefs that if you have them, you should dispense with them. Okay, so starting with this first one at the bottom of the screen, memorizing facts and practicing procedures is sufficient to learn mathematics. I would say that it's necessary. It is an important part. For instance, and it's more important in some classes than others, but just about any class, you got to know your definitions. If the professor's up here yammering and they're talking about linearly independent vectors, well, something should click in you to what that means. Those things at some point just have to become second nature. Now, unfortunately, what I've seen in some classes, definitely not one of mine, is that some emphasize that too much, and then like a final exam becomes a memorize fest. So that's not it's not all that helpful. But it is something that at least it's an important ingredient, but it's not everything. What I've seen students try to do is memorize how to do certain problems. If they have certain practice problems from their homework, just memorize how to do them. But memorized knowledge is fragile. You forget one step, the whole thing comes crashing down. It's not like, for instance, in other subjects where you're trying to memorize something, and if you reproduce most of it, then you may get close to full credit. Not that way in math, because it's very important to understand why these steps are taken, where does that come from, and that makes your basically reinforces your house of knowledge instead of having it crash down on you in the middle of a test. So again, necessary but not sufficient. Okay, math problems can only be solved using a method described in the textbook. Textbooks cannot cover everything, and the higher the level of a course, the less that can be covered. I've seen a bazillion numerical analysis books, and some in the process of running one. They're all different. They all emphasize or cover different things. Some leave out certain topics entirely. I had to make a lot of difficult choices in running this one. And as you know, there are all kinds of resources out there. Actually, any of the books that I've used to teach this class in the past before working on my own, you can find the PDFs for them online. I'm sure that there'll be bootleg copies of mine out there in a few years. But no one writes a textbook for money, so I don't care. And this, keeping with the next thing, teachers and textbooks are the mathematical authorities. No, again, because there's just so much knowledge out there. If I show you how to solve a problem in a certain way, you may well find a better way out there. I encourage you guys to consult other resources if you feel like doing that. I also encourage you to use me as one of the resources that you consult to the full extent, not just during this hour and 15 minutes here. So have a bit more to offer than that. Okay, but we're not the be all end all. Okay, one thing that my colleagues in the department have grumbled about for a long time is that I've noticed that students tend to be very algorithmic in their thinking. That they focus on just here's a procedure for solving this. But what's the purpose for this procedure? What kind of why do we need this kind of problem? What's the importance of this problem? Why did other methods fall short? Why is it we need something different? This is something that I always work into my lectures in whatever class I'm teaching. It's certainly a major theme in the book for this class, but it's something that should not be ignored. Again, these are only parts of a picture. This is a big one. Problem takes longer than 5-10 minutes. There's something wrong with students of a problem. Definitely not. And I can vouch for this as someone who, as a freshman taking honors calculus, would spend literally several hours on one problem. It didn't cause me to give up math, obviously. This is especially important. What? What?
People that had that belief.
Yeah.
Took modern algebra.
Oh yeah, that's definitely a very good class for dispelling that belief. But not everybody has got to modern algebra yet, because it's one of those classes that is often put off for as long as possible. Okay. And the thing is, and certainly again, the higher the level, the more urgent it is to not think that way. But here's where I make a comment about numerical analysis specifically. It's easy for students to think, okay, well, in math is, and this is something that's listed below, that one should not pursue mathematics unless it comes easily to them, unless things come to them just like that. And really, numerical analysis, the whole struggle is actually the point. And the reason I say that is because it's instead of like contrast with other classes like calculus, for instance, or differential equations, where you're learning about these methods and they produce the exact answer and everything's hunky-dory for that limited subset of problems out there. Numerical analysis is about always trying to find better methods to solve problems that can never be solved exactly. There will never be a perfect method for solving those problems. And so since you're already settling for an approximation, but what if you can make an approximation more accurate? What if you can produce it more efficiently? What if you can produce it more reliably? There are what appear to be ceilings on these things with all the problems that we look at. And everyone who's doing research in numerical analysis, this is what I'm doing, are always trying to break through those ceilings. So we're accustomed to banging our head against a wall. We're accustomed to feeling like our efforts are dead in the water, and we keep going. And that's really has to be the spirit in this class too, because you're being introduced to that subject. It's not supposed to come easy. It's not going to, and it's okay. That's the important thing. That it's part of a process. So definitely, it's not about obtaining one correct answer doing it quickly, especially in numerical analysis when all we can hope for is an approximation. You just might be able to get a better one than someone else using a different method. Teachers, the only source of determining whether an answer is correct or incorrect. Oh, don't have that much faith in me. Appreciate it, but we're all fallible, and I still have very strong resentment to my 2003 Calculus 2 class who made me feel as if all I could do was never, ever, 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 ever make a mistake, because when I would make one, it would just throw them into a tizzy. That was at University of California, Irvine, but eventually I set them straight. But yeah, it's again, it's part of a process. Okay. Yeah, okay, your role in the classroom is to receive knowledge by paying attention in class and demonstrate it's been received by producing correct answers. Again, the higher level, the less that can possibly apply. It's just not realistic. Again, I've said it on Thursday. Whatever happens here in class during these hours, is 75 minutes. I don't expect you to walk out of here thinking, okay, now I have mastered everything. No, because it happens by doing, and there is no other way. And that's why I want you guys to get started on these problems before class. At least make the attempt, and then I can help you when your attempts go awry. And that's really a more productive use in class time than me just sitting up here lecturing about all these things that I enjoy and you think are awful, or at least probably half of you would, and nothing really sinking in. So yes, you should pay attention, but that's necessary but not sufficient. It's your actions during class and outside of class that really determine if you're going to master this. Okay. And again, these are it's just a fragment. You're transmitting knowledge and verifying, like by giving you a test, that you received it. It's more to this than just the knowledge. It's about really, as someone who specializes in this particular field, it's my responsibility to not just convey the knowledge of it, but also to, I guess I don't really like using this word, but it fits, to evangelize it, but also to help you guys understand this is what it's like to work in this field. It's not just about here's this algorithm, etc. Okay. And this is one that I would definitely not want a student in this class of all classes to believe, that the process of formal mathematics. Having one way of solving a problem because it's less to memorize. That's just lazy, really. Besides, the problems we're going to look at: how to approximate a definite integral, how to solve a nonlinear equation. Those kind of problems, we're going to learn multiple approaches to solving them. They're going to have their various advantages and disadvantages. And how you pick these methods for different situations is an essential part of this course. And the thing is, there is no clear winner. There are some methods that you could argue in an average sense are better than the others, but there are still certain cases where you would not want to use them, or where it would be a completely crazy idea to use them. That's something I would ask on the exam questions. Why is this method better than this other choice for this kind of problem? So it's more about just executing the methods of themselves, or even writing code to do that. Number 12. Little or nothing to do with discovery or invention, especially not in this field. I remember one of my students long ago was surprised to find that I do research in math. And he actually said, "Isn't math done?" Well, then I'd be pretty bored right now if it was. But now, it's not entirely wrong. It's just a too narrow focus. Calculus has not changed at all its substance in about a century. But all the areas of higher level math that's evolving constantly. There's so much research activity in this field, and yes, I'm on the cutting edge of that. And it's not bragging, it's just true, because what I've done is I've carved out my own little niche, and it's just me and my students, but we would like to have other collaborators too, and we're making things happen, and people are taking notice. And that's what so many others are doing in this field and other ones too. That because the ocean of knowledge is so vast, that anything any of us does, no matter how accomplished we are, is just a little ripple in that ocean. But it's going to help somebody, and like I said, this field more so than other areas of mathematics is really about pushing the envelope and finding better ways to do things. So it's all about discovery and invention, really. Okay, so those of you who happen to absorb the concepts and methods better than everybody else, that still doesn't mean you're going to solve these assigned problems in 5 minutes or less. Maybe some of them, yes. I mean, there's a wide variety among difficulty level among the explorations that I put out there. But some of these are still going to be nasty, and it's not a reflection on you. It's just the way the subject is. Okay. And I'm going to skip this 14th one, but the 15th one, various components of mathematics unrelated. Oh, definitely not. Especially in this class, because what are we doing? We're building on calculus. And then next semester, those of you who come along for a ride, linear algebra, differential equations. So really this numerical analysis is providing another way to solve problems from those fields and other fields. We're just focusing mainly on those three. But even among your other classes, you can help yourself by breaking those walls down. That if you finish your linear algebra class and then just dump all that knowledge after you dumped it out as much as you could on the final exam, you're doing yourself a disservice because those things all come up again. In fact, those of you who have not yet taken modern algebra yet, when I've helped students in that over the years, I see a lot of connections to something simpler, linear algebra, like in certain examples, and that's a way to because it's a special case in a lot of ways, because multiplying matrices, that's a group in the modern algebra world. So this class is a lot easier to see those connections, but those connections are everywhere. And that's what not only what helps you master all these things, but also I think it makes it more interesting. So I just wanted to call your attention to these because, like I said, I've observed over all the years I've been here students having these kind of beliefs, and it's time to get rid of them. And I will add one more just from my personal experience. What I hear from students all the time is, quote, I'm the only one who's not getting it because no one else is asking questions. End quote. Okay. Just making sure it's still recording. And my answer to that has been, more than likely, at this point, the reason why nobody else is asking questions is because nobody is getting it. And then it's my job to try to do something about that, except you guys need to help with that process. And again, whatever the hang-up is, if you're concerned about what your classmates might think or what I might think, and to that, in my case, how I would respond to that is, I think it's better for a student to put themselves out there by either asking questions or by answering questions that I might ask. In other words, just making your voice heard in class and getting it wrong 100 times than to not say anything at all, especially when in some of those cases they might actually be sitting on a right answer or know what they're doing, and they're still reluctant to say so. I've seen that happen where a student actually knows the answer, and I find out after the fact, and then they just don't say anything because they thought, well, maybe they're a little wrong, and they're afraid of being wrong. I respect the effort, and it's something that everybody needs to get past, and it's something that students here in general, some less than others, do have a big problem with, and again, it's counterproductive. So, I mean, if you want to just tune me out, that's fine, but it's only going to be to your detriment. Okay, so I just wanted to put this out there as something, as a way to try to set the stage for what happens the rest of the semester. So, okay, and here's a look at Octave. As you can see, it is a fairly different user interface. I want to see if I can make this larger as well. Okay. Okay, preferences. Okay. All right, so if I try to change the font size, let's see how that goes. I want it bigger, of course. Okay, that didn't seem to do anything. Or that's the editor font. Okay, in the command window, that's weird. It won't let me go bigger than 4? Okay, so I'm not sure. Well, again, I guess most of you are using Matlab. But what's different here is here we have these tabs down below where we have the command window and then your editor. I don't have any files in here yet, but if I were to edit something, well, even I can barely read this. .m. Okay, and ask if we want to create a new file. Then what Octave does that Matlab doesn't is it dumps all this in your when it creates a new file. It gives you it assumes you want to create a function. So here's like your outputs and your inputs and your function name, which is named after a file, and then you would type your code in here, and it has all these comments. Now in Octave, a comment character is a pound sign rather than a % sign like it is in Matlab. So there's certain little differences like that. But as far as the actual statements, since we're not going to be doing anything all that unusual in this class, the language, aside from the comment convention, is going to be exactly the same. So like if you create some code in MATLAB and you send it to one of your fellow students who's using Octave, or vice versa, there should not be any issue with that code working or not. It should just go ahead and work. Okay, and then you have the documentation here. Octave doesn't have it has very thorough documentation, so you can find out about like mathematical operations by sifting through these links here. It's just structured somewhat differently than the documentation in MATLAB. Okay. All right. Now. Okay, then we have here the so your first homework will be all the little explorations that are interspersed in the text of section 1.2. So how many of you have done at least a few of these, or any of them? Okay, well, that's about what I expected. But now the thing is, with this MATLAB section, there's a little bit of an advantage because this is a rather long section, like 20 pages long, so I felt that it was necessary to spend more time on it than just one class period, so that's why I've allocated that much time. But in general, most sections will cover in just a day. So it's very important. Now there won't be 25 exercises on that section because your 5 homework assignments will be on the 5 chapters. You may have that many problems for a whole chapter, but not a section. But it is very important that you look at them. I'm only going to assign certain ones. You'll see I have quite a few in there. Very important that you bring your questions to class. What we may do from time to time is, based on the questions that I get, I may give a mini lecture on certain aspects of the topic at hand. For instance, if a lot of you are struggling with a certain aspect, or I may have you guys work in pairs or work individually. I can go around the room and help. It's a matter of what is needed at the time, instead of me just getting up here and lecturing and then that's the end of it. But it's important that you guys come across with your end of a bargain, and that's why I expect that by the time Thursday rolls around, that not only will you have at least attempted a substantial portion of the explorations, because if you wait until the last minute, I mean, these are due a week from Thursday, seems like a ton of time, but the way I like to look at it, beginning of the semester, is nobody's behind yet. But for that first day, you're at risk of falling behind and trying to put yourself in that situation, because as you well know, we don't have any freshmen here. It's only going to get worse. So So now that I've pontificated at great length, I'm going to ask again. Does anybody have any questions about MATLAB?
How do you change the background color? I know that's not like.
Okay. Oh, like here in the command window?
Yeah, like how do you get it to be black?
Ah.
It hurts my eyes at night.
Oh, okay. So kind of like Twitter night mode? Is it?
Yeah,
Okay.
yes.
Now that's a very good question. You like her to ask questions like that. Or any questions at all. Let's find out because I've done some color changes. Okay. Oh, let's see. Okay, if I uncheck this, use system. Okay. I think we can switch. So you have to uncheck and. Oh, that's weird. Why did? Oh, okay, yeah. White, black. Okay. All right. We have MATLAB at night. Okay. Freaky. Oh, that's interesting. How it also changed because okay, the common colors it seems to be a different shade of green. Okay. Okay. All right. The strings constants were, I think, they were purple before. So okay, cool. I might just leave it like that. Okay.
So did we say these are homeworks in a .fig file and just email that to you, or how do we turn in our homework?
Oh, okay. No, don't send me a .fig.
Okay.
That's really for your own reference. What I would appreciate is if you save it in like a typical image format, like a JPEG or PNG, and if you go ahead and include that in your email, then whether I'm reading an email on my phone or I use Mozilla Thunderbird for my email because Outlook, no. Um, then I can just easily see it. And then what you can also do, like if you have your diary. So for instance, if I were to, well, okay, if I were to say diary off, um, then it would stop writing to the file. As you can see, so it actually wrote everything else in there. And then, so then you can go ahead and include that as an attachment. Or if you want, you can just paste it into the email. I don't really care. I'm going to open this file, actually. I'm going to do edit, and the file name, class underscore 0822.txt. So I'm going to show you guys what a diary looks like. Now, one thing I find annoying about the diary, but I can understand why they do it, is they don't put the prompts in here. And sometimes, so actually what I'm going to do, I'm going to post this diary later, and I'm going to put the prompts in, because then it's easier for you to tell apart your commands that you typed in from the output that MATLAB itself generated. So it would make it a little more readable. So this is, so you can see, every single thing that either I typed in or MATLAB produces output got saved in this file. But now, since we still have about 15 minutes left, I want to resume. I'm going to close this now. So I'll just hit the X here. And then I'm going to, oh, here's something that's keep in mind. I want to issue that same diary command again. So what I'll do is, instead of, if I start to type diary, and then I use my up arrow at this point, it will scroll not through all of your commands, but the commands that start with DIA. So I just hit the up arrow once, and that's the off command, but then I'll hit the up arrow again, and it's the command I want, diary starting a file name. So I'm going to, now I'm resuming writing to that diary. So all the stuff that was there before is still there, unless MATLAB has made some other annoying feature change, which would really piss me off. And then if I do more commands, then it'll keep writing to that file. Okay. All right. Now, yeah.
From sorry. When we're trying to do our homework, do we just do like start new file?
Oh, like here to command window. But yeah, I would recommend doing a diary just so you'll have everything that you did.
So do we need to like exit out of this completely and then reopen it, or like how do we go?
Oh no, because the thing is, by default, when you start MATLAB, it's not writing anything yet. Or like if you so then you can start your diary at whatever point you want. I'm not sure if that's your question though. Is that what?
I think I figured it out.
Okay, all right. Now we haven't got to the point yet where we're creating. I opened up a couple of M files, but here's something else that you can do. Well, did you have a question as well?
Yes, I did. Just when we do our exercises, put all 1 through 25 in one diary and submit that. Is that what you want?
I would prefer that just because when you have a file with a bazillion attachments, but then what you could do is, that's not why it's a good idea to edit your diary before you send it to me. Because, for instance, what if you did a command that went badly? You don't need to include that. I don't need to see every mistake you made. Also, you can add some text in there to clearly separate, or even comments. Like I could say, like, if I start typing a comment here, and then you could do something like this, just to get the ball rolling.
And then you want, like, if there's any output, you want that separately too.
Well, I mean, the output would show up here in the command window, so that would also be in the diary.
Okay.
Yeah, your commands and your output all go in one place.
Okay.
Is diary always a text file?
Yeah, regardless of the extension, yes, it's ordinary text. Oh, why? Okay.
Are we just you always do diary whenever you're starting a new homework? Are you always going to do diary and name it?
That's what I'm recommending. Yes. Because you also have the option of like I can go ahead and like copy and paste this, except MATLAB will only save so much output in this window. At some point, you won't be able to get it anymore. So at least with the diary, you have everything. Which takes me to the next point. Actually, does anyone else have a question first? So here's something else you can do. If I'm just making up a file name here. So if I want to create a new file, and I did this in Octave earlier. I don't know why I'm typing .com. I'm not surfing a web. So, and I'm giving it a .m extension, which is actually the default. Now, your MATLAB that you newly installed will ask you if you want to create a new file. I got annoyed with that message instantly, so I told it to check the box to not display it anymore. But what it does, it creates a new empty file, and I can type my commands in here. Like if I take the commands from before, I'll just take these commands, because I don't want to make up new ones. And I can go ahead and paste them in here, and, okay. Okay, and I'll go ahead and, so here's one thing I can do is, if I'm in my editor and I just want to run these commands, I can hit this run button, the green button right here, and I think it should have the same in Windows. So just to run it, and it'll automatically save the script, and then it will run those commands. And what happens, the way you run the script is you just type a file name right here. And now, in this case, MATLAB did it for me. So if I type homework1 script, actually, I have this figure window that's still here, so I'm going to close that. So if I type at the prompt, homework1 script, it will run all those commands, and then and those commands, in this case, produce this plot. And you don't include the .m extension. Now, the reason why you might want to do this is, suppose you're running a series of commands, and maybe you find yourself messing up, and it's a pain to go through all those commands again. If you have them saved in here, you can change whatever you need to. You can run it as many times as you need to with whatever changes until you get the output that you like. And this is something very common to do anyways, to have these scripts that run whatever commands. Later on, you'll be writing functions that are your own MATLAB functions on top of the built-in ones, and you can call those from your scripts as well. In fact, for my research, I always have some top-level script for testing purposes, and that script will call my functions that do the actual work. So this is something that you might find useful. For simple exercises that we're starting with, you can probably get by just typing things at the prompt, but if you find it's problematic, again, because of mistakes or whatever, or needing to change things, this is something that I would recommend is using a script. Okay. And whatever is a file name for the script, that's how you call it at the prompt or using the run button without the extension. So MATLAB assumes that any .m file is a file full of MATLAB commands. Okay. As opposed to if I want to make a function, that is also a .m file. You create it in the exact same way. Actually, I'm going to turn off night mode here because I'm concerned about that not being as readable. Well, that would definitely not be readable. Okay. Okay, so I want a function file. You create the same way, but to make it a function, you start with the word function. I'm going to make a very simple function here. All it does is it's a function for squaring. So I'm going to. Okay, so y is the output and x is the input. So input. Oh, whoops! I goofed. I had to name my function after the file. So that's why. Actually, my mistake is helping me present something useful to you guys. If I wanted to call this function my_, I should have called my file mysquare.m. But I just made this up now, so I wasn't thinking about that. Notice MATLAB has highlighted it, and there's a little squiggly line underneath. And over here, you see this orange. That means there's a warning. If you see red over here, you've made a syntax error. If there's orange over here, there are warnings. And now MATLAB will allow me to fix this by changing the function name to match the file name. I can click on Fix here, and now that's changed. And notice over here, now we have green. That means we're good to go. There are no obvious syntax errors. There are no warnings. X is the input parameter, and y is the output. That is just the square of whatever x you put in. So this is an idea of how a function works. You can have any number of input arguments. You can have any number of output arguments as well. And this is discussed more in my textbook that you should read. So if I go ahead and save this, and then I want to call this function, I can call my output whatever I want. B is equal, I'll set A equal to 4, and then B is equal to homework1 function of A, and sure enough, it squares it. And it doesn't matter if it's anything that can be squared. Like, I'll make a 2 by 2 matrix. So 2 and 3 in the first row, 4 and 5 in the second row. And I like to refer to matrices using capital letters, as all textbooks do. So now it'll take that matrix, and it'll square that. Now, if I give it a vector, just a vector like 2 and 3, for instance, well, you can't square a vector. So it complains. And it says for exponentiation, one argument must be a square matrix, the other must be a scalar. Use power dot up arrow for element-wise power. So MATLAB's come a long way in terms of giving helpful hints if it thinks it knows what you did wrong. So if I wanted to be able to square vectors, I should have used a dot up arrow. But that would mess up squaring matrices, so I have to be careful about that. Okay, and so B retains the value from the last time I ran it. That's this matrix. You can see the values here. So since it's only a 2 by 2 matrix, it has the it can show you all the values. But I can make a random matrix. Let's see how big a matrix I can make. Well, let's try 10,000. 10,000 rows and columns. Okay, and now I'm going to square it. Now I can leave out the semicolon, which of course is well, no, actually no, I'm not going to do that. I'm supposed to see how long it takes. It's taken a while because multiplying a 10,000 by 10,000 matrix, which has 100 million entries. So actually, I think by the time this is done, you guys will have all left. Yeah.
You can see your homework one function.
Yeah. Okay, well, since this is busy anyway. To interrupt this, Control C interrupts, except now it's... Okay. Okay, it worked. All right, so, yeah, that was a bad idea. Okay, here's the function again. Oh, you tried it and something went wrong?
I just don't know what it's doing.
Oh, okay.
It's saying error in line 4.
Oh, okay. Let's show me. Okay. You have to specify an input. So your function is fine. It's how you called it that's a problem. So notice I put something to square. Yeah. Now, one thing I want to point out. Okay, we're almost out of time, but I can have time for this. And I did this deliberately. In this function, I call the input, I refer to it by x. The output I refer to by y. But those names only apply within the function. Whereas here, the input is called A, the output is called B. So they're independent of each other. So the variables you have here at this top level, with your top level workspace, is separate from a workspace of a function. So this matrix that I specified as A, it becomes known as x in here. Y is computed. Then the value of y is copied into b, to b out here. So if I have x, if I have a variable x here and a variable x in my function, they're separate entities. They just happen to have the same name. So it's one thing that's very important, that there's this disconnect between, and in computer science parlance, a is referred to as an actual parameter, whereas x in the function is referred to as a formal parameter. So it's important to understand that the separation between the two. And this is discussed later, like in the section of the textbook. It's about functions, where I have you try some things to show that, so you can see for yourself that they really are different. Okay, it is 5:05, so we're going to stop. And apparently the recording went fine. I'm going to